tape recorder has been a big benefit to us in passing some of the time away in our transit out to the moon. The crew of Apollo 13, wishing everybody there a nice evening, and we're just about ready to close out our inspection of Aquarius and get back for a pleasant evening at Odyssey. Good night.
It was plagued by bad omens and bad luck from the very beginning.
13, we've got one more item for you when you get a chance. We'd like it to stir up your cryo tanks.
It never really converged to the point where you felt you really had total control of what was going on.
Okay, stand by.
About the time you'd turn the corner, something new'd show up.
Hey, Houston, we've had a problem here.
By the time we came on duty, we were well aware that we had a big problem on our hands.
Can say again, please.
It was life-threatening.
Houston, we've had a problem.
It was not about landing on the moon in the right place. It was about survival.
Maybe most wonderful.
Stand by, 13, we're looking at it.
Saturn V building up to 7.6 million pounds of thrust, and it has cleared the tower.
This is Mission Control Houston. We appear to have a good first stage at this point.
Here we go. Okay, Fata. We're go flight. Looks good here. Guys, that's a good flight. Okay, Econ, GNC. Looks good flight. Looks good flight. Okay, 30. Looks fine.
The crew was Jim Lovell was the commander. Jack Schweigert was the command module pilot. Jim I had worked with as a backup crew on Apollo 8. When he flew Apollo 8, I was the backup lunar module pilot on that mission. And then we worked obviously as a backup crew for Apollo 11. I backed up Buzz Aldrin on that mission. Jack Schweigert, because of a measles threat, replaced Ken Mattingly 2.5 days before launch. So that was something that never happened before or since, I don't think, on a mission.
Flight Dynamics Officer says the trajectory looks good. We show 1/2 mile in altitude at this time.
We had 4 teams in mission control. We did this from a standpoint of easing the shifting schedule, being able to train for very specialized events during the course of the mission. And then one of us always designated as sort of a lead. And basically the objective of the lead was to address any crises that come up to get your team off the console, and the remaining 3 teams would continue 24/7 support for the mission, as well as picking up a lot of the actions related to the getting the crew back home. I happened to be on console at that time, and we're just right at the very end of our shift. We're preparing for crew sleep period, and one of the last things you do is take a look at the cryogenics and see if you need to stir them up, make them uniform. So you got equalized pressures going into life support system and the fuel cells.
We've got one more item for you when you get a chance. We'd like it to stir up your cryo tanks. In addition, I have Shaft and Trunnion
Okay.
for a look at the Comet Bennett if you need it.
Stand by. Hey, Houston, we've had a problem here.
Can say again, please.
Houston, we've had a problem.
Glenn was coming on with his team at that time, reading the log, preparing for handover.
By the time we got to handover, we knew full well that we had to take care of this thing in terms of an emergency. We were handling something that we knew was out of control. And in this case, every team that came on was dealing with a major set of problems.
I assume you've called in your backup ECOMs? Flight, say again? Have you called in your backup beacons now? See if we can get some more brain power in this thing? We got one here. Roger.
We had this loud bang which kind of reverberated with a little echo because the vehicles we're in were metal vehicles, and it was kind of like you're in a big barrel and they hit on the side with a sledgehammer kind of sound. In the tunnel area, some of the metal was actually crinkling, kind of like you take a Coke can and squeeze it, a little crinkling. So the two vehicles were moving not together, but a little asymmetric, I think, in roll, and that was causing that stress in the tunnel area.
I went down into the command module and saw that we had lost 2 of our 3 fuel cells, that they develop oxygen. I then looked out the window and saw escaping at a high rate of speed a gaseous oxygen, and it turned out that oxygen that I was examining was from the second tank, because the explosion occurred on the damaged tank, but that also ruptured the second tank. The first tank just blew the entire side of the spacecraft off.
Here is a bulletin from ABC News. The Apollo 13 spacecraft has had a serious power supply malfunction that could cause the lunar landing mission to be terminated early. At the moment, the astronauts are continuing to try to isolate their trouble. A late report says the spacecraft now is operating on battery power alone. All unnecessary equipment is being turned off.
Oh, within a couple of minutes when I got to my position, from looking at the instrument panel, 2 meters had the needles on oxygen tank 2 in the bottom, and they were fed by different sensors, which are unlikely to fail at the same time. So I knew we lost tank 2. Without looking at mission rules, I knew that was an abort.
Here in mission control, we're now looking towards an alternate mission, swinging around the moon and using the lunar module power systems.
Although we spent lots and lots of time thinking through all the mission rules, when it really happens, like in this case, we didn't have to open any books to tell us what we had to deal with.
Tell me you from flight. Go ahead, flight. I want you to get some guys figuring out minimum power in the LEM to sustain life.
Since the cryo-oxygen tank blew up, it ruptured the other lines, and we lost all oxygen supply to the fuel cells and the crew module. And the crew module was dying real quickly from lack of power other than the battery, and we didn't want to use the battery because we needed that for entry.
This is Apollo Control at 57 hours 46 minutes ground elapsed time. The black team of flight controllers is now on station in Mission Control Center looking at possible alternate missions, as we have an apparent serious oxygen leak in the cryogenic oxygen in the service module. And now in the process of powering down the command module. Less than 15 minutes remaining of electrical power to the CSM.
The biggest things we had to do in the dying moments of the electrical system in the command module was to transfer the guidance system from the command module to the lunar module. And we only had about 15 minutes to do that, because if we didn't get the guidance system in the lunar module, that meant that we'd have to start all over again to try to get the lunar module guidance system up to speed.
This scheme of going across to the lunar module, still connected with the open tunnel, the lunar module would serve as a sort of lifeboat for the crew of Apollo 13.
And then we started turning on all things, the control systems. We were starting to talk out from the lunar module. And in fact, we were in the lunar module before the ground realized it, and suddenly realized that, oh, they're over there. And then, of course, what they had to say is, we're going to have to get you off the course you're in now to get you back on the free return course.
And this meant that we were no longer on a path that would allow us to be swung around the moon and come back towards the landing spot on the Earth. The controllability of the spacecraft was okay as long as we had our indicators up, because we had practiced that, as I had said. But suddenly, to save power, we shut that down for a while, and we had to control it by only looking at our computer display. And I had never tried that before. I really don't know who had, and it's a very difficult task. And we spent a lot of our first part of our emergency or survival time just learning how to control the spacecraft in this mode.